Good evening, ladies and gentlemen. Oh, wow. Everybody's listening to me. Welcome to the Namibia Scientific Society. As you can see, we have set up for Zoom participants once again as well. And Miriam just told me that we already have over 17 participants. Okay, 20 participants. Welcome all Zoomers. Please be reminded that this presentation will be recorded and will also be made available on our YouTube channel in a couple of days. To accommodate the listeners from near and far and the ones here today and the ones listening in the future, I ask that every person please wait for me to hand them the microphone. We cannot have questions out of the audience without the microphone, because then the people on Zoom and later on the YouTube channel will not be able to hear the question. So please allow me to give me the microphone. And for the people on Zoom, Miriam will read the questions from the chat, if time allows, if we can still sit still. Over the last couple of weeks, the fairy circles have been the cause of several heated discussions, once again. The Namibia Scientific Society prides itself in giving scientists, stakeholders, and interested laymen a platform to meet, to exchange ideas, and to present information. This platform has been and is to remain neutral and everyone treated with respect. Hence, as always, no slandering or disrespect will be tolerated or entertained. The magic of fairy circles has fascinated Namibians and visitors to Namibia for many years. Over the last couple of years, over these many years, different hypotheses and theories have surfaced. Some have been discarded, some have resurfaced. The ones that I have heard of are the alien landing place theory, the game wallowing theory, the euphorbia toxicity hypothesis, the geochemical gas hypothesis, and the self-regulation hypothesis. In February, we had the opportunity to listen to Dr. Gensin, who presented the theory and his research on water stress being the cause of fairy circles. Today, we will have the opportunity to listen to Professor Dr. Jürgens and the termite theory. Professor Jürgens is no foreigner to Namibia, as he has been studying the vegetation of the Namib for over 40 years. His research has focused on evolution and functional adaptations of plants and ecosystems to the extreme environmental conditions in deserts and savannas. And of course, he also became fascinated by the magic of fairy circles. The result of his fascination and decades of research have now resulted in this book. And yes, it's very heavy. And this book was published in the Hess Verlag at the end of last year. As can be seen on the cover already, this publication has involved over a dozen contributors, of which one, namely Felicitas Gunter, was also a part, and she's also here today. She has specialized on termites, and I was told she looked at them all close up and found some wonderful things. And she will also present a couple of slides and give us a bit of information. But without further ado, I now ask Professor Dr. Jürgens to please introduce herself and give us some more details on this.
Thank you, Ruth, for the nice introduction. Thank you, Scientific Society, for inviting me. I think this is the 4th or 5th time, and I think I've been here already 2 times for fairy circles. So I hope you don't get tired of what I report, because I still believe in what I presented here in 2013. However, there's a lot of new stuff, and therefore this book is quite rich. On 376 pages, it's completely impossible to present the knowledge in less than 1 hour. So let me try to tell you the most important elements of the scent termite hypothesis that not only I believe in, no, I'm convinced of. I have data, and I want to show you lots of data. In the book, you will find a wealth of data, but this cannot be presented here in 1 hour. So thank you very much for the new invitation. I don't see this screen now, but I think I know all the others. Can we darken the room a little bit? Otherwise, the color and the details may be not so good. Okay. Now this doesn't work, also interesting. It worked 5 minutes ago. I must go back to the PowerPoint, I believe. No, no, this is now a strange satellite image. Let me try here. That looks good. Let's try this one. And I make it large. No, it doesn't want to be. The other is on or off. We must close the one first. I'm very sorry, but with the Zoom, yeah. Well, that's good. Dann fangen wir die neu an. This looks good. Yes. Thank you. I hope we are here now. Yeah. Okay, just one starting picture of north of Sesame. Yeah, and my summary, I still think the fairy circles of the Namib Desert are caused, created, but also maintained by sand termites. And by doing that, in my eyes, they represent a global masterpiece. I mean, best of them all on the planet, of ecosystem engineering, better than the beaver in Canada and many others, performed by small social insects and made possible by the unique environmental and evolutionary history of the Namib Desert that experienced an aridity of at least 14 million years. Some geologists can tell us in more detail later. Yeah, I already told you that the book is extremely comprehensive and we cannot bring it up here. So I will focus on what I published 2013 in the journal Science. And that article, as you probably know, has been reprinted by the Scientific Society completely with all the attached online material that in such high-ranking journals is not printed normally. So you find the whole story with all data already in your own journal from 2013. And the new book is now a much wider monograph, a monography that really touches each and every aspect. There are more than 700 figures and tables. There are 15 co-authors involved from microbiology, from soil science, molecular genetics, entomology, botany, ecology, and all that goes even far beyond fairy circles. We will read about Huvelkies in Namaqualand and the Spurgebiet and other similar things. But tonight, the focus must be the sand termites and the fairy circles. We are open for discussion after the presentation. And I believe even for scientists, the biggest problem in the debate about causation is that few people spend enough time out there in the Namib Desert to really experience the facts. And therefore, I've offered a 2 days excursion to the fairy circles that are spatially closest to Windhoek, and that, to my belief, is Duprevier and Namib Desert Lodge for our driving time from here. And I'm grateful to Manny Goldbeck and Gondwana to make that possible. I already offered Ruud and the Society to also have an excursion to Gudibisvlakte or Marienfloss Valley, the much larger fairy circles in the north, or even to Angola, or even to South Africa. All that is possible, and that allows then really in-depth discussions. Okay, let me introduce you a little bit. Yeah, I've been professor at the University of Hamburg in the Institute of Plant Sciences and Microbiology. And there I've also been the head of the research group Biodiversity, Evolution and Ecology. And I was director of the herbarium, the plant collection at Hamburg, until I had to retire April last year. And that plant collection is one of the largest on Earth. 1.8 million plants are stored there, dry plants. I think it's ranked number 20 in the world. And we also, in the greenhouses, have the largest live plant collection of living stones, facies. So it's a real good place to study the Namib Desert, and that's what I did. Yep, and therefore I had the opportunity to very early define even floral kingdoms of Africa newly. So with 2 publications in 91, 97, I proposed that the Cape flora, which was only this dark area down here, should be doubled or even more enlarged by adding the succulent karoo in Namaqualand, in this Berggebiet, and even the coastal zone of the succulent karoo in Namibia up to the Kunene River. And that was accepted by everybody, and also Sanbi, the colleagues in South Africa, now print books that have a title, The Greater Cape Floristic Region. That is what I proposed at that time. I also looked at much more detail at the vegetation in terms of composition of plant species on plots of 1,000 square meters, okay? That's about this room, a list of all plants and how many there are. And then you classify that. So for the vegetation map of South Africa, 2006, I did several dozen units here in the Richtersveld, northern Namaqualand, in the desert biome, succulent karoo biome, and also the fynbos biome, because here on the highest mountains, there is fynbos, there is Cape flora. Okay, the same for Namibia, has not yet been published. Only the central Namib Desert, we published in a team in 2012, from the Kwisa to the Uchab, a map that you can also download in Google Earth and overlay on your maps. You can use that, you find it in the internet. Yeah, and my main topic was evolution. How did this large desert over these millions and millions of years get filled with plants? And so, for example, we studied in a team Welwitschia, and previously, 2 years ago, published in a quite high-ranking journal, the evidence. The evidence, here's a problem, I don't know why. The evidence that there are 2 subspecies, zoologists would even say species of Welwitschia, and they both occur in Namibia. The boundary is in Kaokofeld. So you have 2 Welwitschias now that will be studied in more detail soon. And this is my last introduction slide, just to tell you that over 43 years, it was my main ambition to study the spatial aspects and the change in time of the Namib Desert comprehensively and with repeated visits of observation, including experiments. And with these data, I have now this fantastic data bank of 20,800 releves of 1,000 square meter, all these dots from middle Angola to Knarschvlakte. And that is my real ambition, to get out a book on the vegetation and flora showing the whole map. But the monitoring is also extremely important, especially as now we have dramatic droughts, really a collapse of the vegetation, especially in the south of Namibia, in Richtersveld, but also in the northwest. Yeah, and that also includes the ferry circles, which in that observation formed part of the daily work. And so my first ferry circle, my first school day, no, my first ferry circle, I saw in February 1980. And this is a photo from September 1981 at Numi's Richtersveld National Park, and they are still there. And I saw them each and every year and started to measure them. Okay. Ruth already introduced the other hypothesis. So the slide, I don't know whether I shall repeat it. The effects of dead euphorbia shrubs. I mentioned a few people. The toxic gases, where Willy Jankowitz from Windhoek and Gretel van den Rooyen from Pretoria started, and later others followed. It's very interesting, and I have similar data. The self-regulation hypothesis, now sometimes discussed even as swarm intelligence of grasses, also has lots of publications, probably more than any other. And the scent termite hypothesis I published first in Science, and it was reprinted here. And meanwhile, there are many papers, mainly with colleagues from entomology, soil science, and other disciplines. Okay, fairy circles. Now let's have a look at fairy circles. And unfortunately, we must start with a definition, because fairy circle is such an attractive term. There are too many linguistic borrowings just using that word. For example, right now in February, in Science, a paper was published talking about hydrogen coming from geological layers from the depths, and they are called fairy circles as well. In the past, with a vegetation map, we mapped these fairy circles, not knowing that they are fairy circles. We called them pans, as in the Kalahari, and in fact, they are several hundred meters in diameter, so you will never mix them up with Namib fairy circles. As a biologist, I define plant species and many other things following the type principle. The type is a plant or an animal that was the first discovery of a new species. And then this plant is pressed, dried, and brought to a herbarium, or the animal is put in alcohol. Termites and alcohol, and brought to a museum. Many of these termites come from the National Museum, not far away from here. And then this is the type specimen, and the name is connected to this one specimen, and you cannot change that. And therefore, I propose that Kenneth Tinley's first documentation is the type. And here's a photo published in 1971 in African Wildlife. And Kenneth Tinley, who was an excellent ecologist and vegetation person working in Angola, in Namibia, in South Africa, in Mozambique, and Australia. He comes from Australia. We wrote circular bare patches, probably fossil termite mounds, now truncated. So he smelled a rat. He says termite, but obviously he thought about the big Omayoba termites having a big mound that then gets eroded. Okay, if that is a type, I go there again. That was my last visit, May last year, and the fairy circles are still there in a sandy plain. And in that sandy plain, I see sand termite nests at the margin of a fairy circle, sand termite soildons, sand termite galleries over grass that they eat under the sand gallery. So I'm quite happy with that definition. And if I look at the subsequent publications, this is in line because they all take up the topic in northern Keukenveld, often in Marienfluss Valley, sometimes in Gebietsvlakte. Yeah, Tinley, I told you, Terron followed 1979 and developed that euphobia toxicity idea in the Gebietsvlakte. 1982, Eicher and colleagues came and tested all bacteria and fungi, had a nice list, considered they may be important, but no final conclusions. Eugene Moll from Cape Town also went up there and made a long list of many ant species and termite species and considered they may be relevant, don't know which one, maybe a combination, first ants flying in, then termites following. Where are we? 1997, I had the privilege to be the first author of a paper with Antje Berkey, Mary Seeley, and Casey Jacobson, in which we still use the term fairy rings and said, yeah, causes unknown in a book in Cambridge University Press. Then in 2000, there was a publication by my PhD student, Thorsten Becker, in the Acacia project we had at that time at the University of Cologne. And at that time, Stefan Getzin accompanied Becker as a field assistant. And they published then harvester termites shall be the reason. And they used a relatively simple model of termites coming out of the hole, running to eat a grass and bring it back. That was then answered by Sabine Grube, a termite specialist at that time at Gobabeb, and she said completely wrong because the foraging habit of Rhodotermis is very different and would not result in circles. But Becker, now without Getzin, published again in 2001, it is the fact, and again in 2007 even. Okay, in 2004, Grete van Rooyen and many colleagues tested many hypotheses, fairies, radioactivity, etc., and also came up with the awareness there must be more research. Yeah, and then I proposed the sand termite. All this happened using the northern Kaukofeld. So I think, please accept this is my definition. I can live with it. Okay? And now my next question is, do fairy circles have any common environmental properties beyond being bare gaps and beyond having, in my opinion, sand termites involved? And then I mentioned 2001, when Karl Albrecht from Stellenbosch published that at the end of the rainy season in April, the soil beneath the bare patch, the fairy circle, is moister than the soil next door between the fairy circles, or in other words, beneath the matrix vegetation. We all use the word matrix for the ground structure of normal vegetation, comparing it to the specialized thing. Okay, this is interesting, and I thought this must be studied in more detail. And especially the question is intriguing, how long does the water remain? Because he only looked at it at the end of the rainy season. And yeah, I was wondering, I mean, this is a photograph Snake sitting here took for me, thank you, in February 2021. And this is after 3 years of drought. And one fairy circle, the second one, the third one. You wonder, is it possible that here, roughly 100 millimeters mean annual rainfall, under such a climate, is it possible that there's still water left? Probably not. Or also the ring of grasses seems to be dead. On the other hand, we all know about these pictures where only the plants being next to the bare patch are green, obviously indicating access to water. Plants don't lie. They would be dead if there would not be any water. So in the 1997 years, in my research team in Cologne, already I proposed to be a bit more specific with the naming. And I said, fairy ring is nice and highlights the ring of green grasses, while fairy circle rather highlights the bare circle. And I generally propose that we should not use the term fairy ring because it's so close to the German Hexenring and other rings in Germany made by mushrooms, which are a very different thing and really only rings. So fairy circle would be better, but there may be good reasons to talk about fairy rings as we have them here. Okay, so the terminology I propose is, here is a fairy circle in the middle, a fairy circle from De Previer, where we have the excursion, and that can be called bare patch or also fairy circle, why not? Then we have the fairy ring, a hedge-like belt of tall and, very important, long-living grasses. All the others here only live a few weeks, months, not a year. So these live longer than a year, and in botany, we call that more than a year perennial. The Latin word annuum, year, is inside it. Sometimes I just say luxury belt because the grasses grow so luxuriously, and it looks so beautiful. Okay? And then we have the short-lived and small grasses around that we all call the matrix vegetation, and they are all dead. And yeah, we even had recent publications, Kappel et al., who with genetic methods proved that all these grasses have to germinate from seeds. So there are no processes starting in the center and growing to the margin involved. Each of these bloody grasses had to start from a grass seed. And the only difference is these live several years, and these only live normally after rain only a few months, sometimes up to 2 years, under really good rainfall conditions. Okay, if you accept that, this is a schematic graph, and we accept that there is stored rainwater somewhere, but we don't know how much and how long. And this is now the research question, but it's important at this stage to make everybody aware you have a most fascinating wonder of nature in your country. These fairy circles are not a damage, not something missing. It's not an accident that took away the grasses for oryx, for gemsbok, for springbok, for ostrich. It's the opposite. These are oases. These are thousands and thousands and thousands of oases in a harsh desert, in really dry desert, 100 millimeter or less. 100 millimeter I mention often because in the Sahara, that is regarded as the boundary of absolute desert. And below 100 millimeters, there's nothing. But here you have these oases. And this is perhaps the most important message one should convey. But let me add, there are strange variants, for example, mainly in northern Namibia and in Angola. In addition to this perennial belt or luxury belt, there's another belt that can have 10, 15 meters width, and I call it the halo. Please see how far away the next fairy circles with their halos are. These are many hundred meters. It's hard to believe that there's interaction, especially as in between there's almost no vegetation. Okay, these are pictures from west of Hartmann Valley. After a good rain, they look beautiful. Yeah, and these halos from the air, from the satellite, are also quite interesting. Ugh, bad picture, because the halo is visible here, but you can find many pictures where the halos overlap. And if they do that, in the end, you come up with landscapes like this, where you have a continuous grassland around fairy circles. And then it is possible that here, the activity of the termites or something else has turned desert into permanent grassland. And that is really, yeah, a masterpiece of ecosystem engineering. And when I published all that in 2013, I got very grumpy letters from Canada and had to spend half an hour in front of a camera to explain the Canadians that the beaver, the national animal of Canada, is now no longer the #1 for ecosystem engineering, because yes, the beaver makes longitudinal rivers becoming lakes, but yeah, what the termites do here to turn desert into permanent life is much better. And the presence of water allows so many animals to live there. So it's also a source of a rich biodiversity that we present in the book in chapter 8. Especially Joe Henschel, the former director of GOBABEP, has written that chapter with all these animals. It's fascinating that there are spiders that specialized on sand termites and live in the depths of the fairy circles. Okay, so now I ask a question I already answered. Is it possible to identify one organism that creates the fairy circles? And I say, yes, I already wrote that. It's a sand termite. If I tell you all this like that, it's a bit funny, but I want to make you aware that this is really fact. And perhaps in this room, there are some more people who have seen that. Felicitas, PhD student, has seen thousands and thousands and identifies termites easily. Snake, thank you very much. You spotted termites where nobody else found them in all these regions, and you were really the best, detective. Yeah, Imke, where's Imke? Also Imke. She accompanied, I don't know how many 100 student excursions, and there are many bachelor theses, etc. So yeah, and my wife, Irma, hand up, please. Yeah, we also, she's also a witness. For example, in this fairy circle studied by Ravi near GOBABEP, where nobody saw termites in 2017, we both saw them in 2012, short after the gigantic rain of 2011. But since then, there's dryness, and 5 weeks ago, I paid a visit to Eugene Murray and Gillian Max Culling, and they said, for 11 years, no rain. And I say, yep, so we have to wait. The next settlement of termites may come after the next rain. These are all indicators of termites. The termites themselves, soldiers, workers, the alates that fly out of a nest, the alates that land, I guess, in front of the woman and the king behind. They kick off their wings and then go into the ground and become king and queen in a royal chamber, well defended, in a nest, mostly in the depths. And you see often soil dumps where the tunnels end at the surface. You see these sand galleries under which they eat even green living grasses. They do that. It has been shown with experiments. So all these are good indicators of presence of termites. And before I hand over to Felicitas to tell us more about, yeah, now this collapsed, that is very sad. I go to one area that I must open, otherwise it would take longer. I want to convince you that we do a good job, and I do that by showing you our data bank. This is a data bank with more than 1 million plant records, and I regard the fairy circles as a vegetation record, even if it's a gap. And I nevertheless count all plants and animals there now for 43 years. And if you have that in our data bank, we can select, well, from these 20,000 plots, here we are. We can select with, oh, it's not here, sorry. You must warn me if you don't see anything. Let me try. I do see it here. What must I do to see the other program? Must I really jump out of the PowerPoint again? Okay, let me try. I make it small, not good enough. So maybe I have to close it for a minute. What is not a drama? Nothing? No? I'm so sorry. Okay, then I give up. I wanted to show you 1,800 fairy circles all popping up in a satellite map from mid-Angola to the south. I hope you will find it in the digital material. I understand the Zoom and the YouTube later will have all the presentations. I think it takes too long. Then I carry on with a PowerPoint. And rather, Felicitas carries on with the PowerPoint. Yeah, there we are. How did you do that? Okay. Yeah, no, I don't see it here. Okay. Let's stop it. We carry on with the PowerPoint. Let's take a decision, really. It's better. Nee, jetzt machen wir PowerPoint, sonst verlieren wir zu viel Zeit. I'm sorry. Okay, where are we? Those we had seen. Here we are. And here we are. Exactly. Okay. I would have shown you a map of 1,800 fairy circles that have different colors from Angola to the Cape. And this is not a funny idea to make them colorful, but we can, as a team, and I mentioned a few people in this hall, we can recognize the different fairy circles by their morphology and distinguish them. This lady can distinguish them by the genetics of the termites she found in them and she collected. Must I do anything with a microphone? No.
Okay, great. Good evening. Yeah, thanks to be here, the Scientific Society. And yeah, I'm Felicitas Gunter, PhD student and lab manager in Hamburg. And yeah, since 2015, I traveled here each year once or twice, and to Namibia, South Africa, and Angola, collecting termites in all of these 3 countries, mainly in the fairy circuits. And yeah, and I analyze them morphologically or molecularly. And my main topics are the genetic diversity, population genetics, phylogeography, or the morphology, mainly on the sun termite species, Pseudotermis velocis, but also on other species, for example, from the family Rhodotermitidae. So as a first part, I would like to show you results of the diversification of the sun termite Pseudotermis velocis. And based on 113 collections I made, students made, Norbert made, and others, we were able to determine a high genetic diversity based on barcode marker CO1 or CO2. And as a first result, I would like to show you the genetic tree, starting with the most basal group, that is the succulent karoo, and collection of these groups occurring in the sunny plains of the Richtersveld, the western part of the Spurgebiet, and Lüderitz. And they all occurring in the winter rainfall regime. The next two groups are the Tsao-Kalb group and the Southern Namib groups, both occurring in the summer rainfall regime. And especially the collections from the Southern Namib, they're occurring in areas without woody plants, only grasses. The next three groups are the East Garib, southwestern Kalahari, Nama, occurring mainly in Namibia, but also partly in South Africa. And the last two groups are the Western Kalahari Basin, which has a wide distribution, and the Northern Namib group, occurring from Gobabab up to the Yona National Park in Angola. And regarding this phylogenetic tree, we conclude that Psammotermus allocerus cannot be regarded as one single species, but as an aggregate of 8 closely related species. And following the type specimen argumentation Norbert did, that in the future, the succulent karoo group retained the name Psammotermus allocerus due to the type specimen from Lüderitz, which you have here also in the museum and Windhoek, really nice. And the other 7 species will get 7 new Psammotermus species name. And this classification is also supported by morphological analysis of the mandible shape of the soldiers and 25 more characters, which you find in the book. And as a second result and data, I would like to concentrate on the population genetic of the sun termite Psammotermus allocerus. So for that, we measured, analyze, and investigate the local genetic diversity of one Psammotermus colony from one ferrous cycle, comparing them with another Psammotermus colony from a neighboring ferrous cycle. And we formulated 2 hypotheses. The first one here on the left side is each ferrous cycle is inhabited by a sun termite colony that migrated directly from a neighboring ferrous cycle to another one. And the second hypothesis is, on the right side, each ferrous cycle is founded by a new king and queen from further away. So they fly in, landed, and found a new colony and a new ferrous cycle. So, and that is one result, which is also in the book. And you see here the genetic distances of termites from 7 neighboring ferrous cycles in deep revier. And you see 2 results. First of all, you see a low genetic distance of termites from one colony and ferrous cycle, so they're closely related here and here. And secondly, a high genetic dissimilarity among termites of neighboring ferrous cycles. And we conclude that each ferrous cycle is inhabited by one Psammotermus allocerus colony that is genetically different to a colony from a neighboring ferrous cycle. And this result supports the second hypothesis, that ferrous cycles are founded from a new king and queen that fly in from far away and found a new colony and a new ferrous cycle. Yeah, and that's all from my talk. And now, please.
From the mic to the ear. Thank you. Yeah, it makes sense that Felicitas at this moment shows around a few simple collections of sand termite nests collected at Deep Riviere, thanks to Gondwana. And there are also probes with ethanol and termites inside. We promise there are no living termites that can kill your house. Okay. While Felicitas starts that, I carry on if I can. Yeah. Okay, that would have been the map I would have produced with the data banks. But now you see all these different colors. Huh? Each color is a group of not only termites, but also construction types of fairy circles. And for all fans of Namibia, we have included a huge chapter 6, only showing lovely photos for all these regions from Angola to Namaqualand. And we always show the fairy circles and the termite nests and all these things. So yeah, this is all, each of these spots, 1,800. Each of these spots has been inspected, and we found one of the many indicators I showed you on my little collection where termites, termite nests, termite tunnels, and all that were shown. Okay, so we believe these are all fairy circles inhabited by sand termites that are also originating. This includes Angola. I heard discussions that there are no fairy circles in Angola. This is Iona National Park. Behind that mountain is Espinera, the head office of Iona. And this is a dune where Felicitas and Imke, together with me and Bruce Bennett, collected termites from here. Further to the coast, you have welwitschers at the margin of fairy circles. They are there for sure. And yeah, Wolf Hake showed me that snake, and Wolf Hake, his brother is here, also showed me the sand galleries and the Psammotermis termites there in August 2007. Thanks to Wolf, he was the first pointing out to me the name. This is Psammotermis. Wolf was a famous herpetologist from Transvaal Museum. Okay, let me try. Yeah, I'm a vegetation person, a botanist from training, so I always look at all the plants. These are the dominant grass species from Angola down here, and they are very different, and some have never been mentioned before. You find them in a book also as a catalog. And most important, down here in the succulent Karoo, the grasses are not important at all. But woody shrubs are important. Well, not shrubs like that, normally dwarf shrubs, 50 centimeters. And they belong to the facies, to the living stones or Asteraceae. Here's just a list. And they, inside them, fairy circles are produced. So there are no grasses involved. What makes me hesitate when swarm intelligence of grasses is mentioned, here are no grasses. The grass layer is often completely missing normally. And if there are, then there are only a few. Okay, so it's very important to show these landscapes as well, because many people never traveled there. This is a fairy circle with Psammotermis termites, part of the genetic analysis with Sarcocaulon, Bushman candle, and all these other mesons. And if you look at the detail, you find these typical living stones and Xanthopamelia walteri lichens. This is a very different world, and I would say the sand termites eat holes into any vegetation they find. Also the grasses from Angola to the south are no special grasses. They are always the normal grasses in that region. Okay, this is another fairy circle with Braunanthus pseudoschlichtianus, huh? No grasses. So I think this is very important to be aware of. And from here, I'll quickly show you the ecology that has been shown by others as well. Mean annual precipitation is the rainfall. Yellow is below 100 millimeters, a proper desert. And you can see the fairy circles exactly follow that line, even in the south, where the Orange River Valley has this low aridity. They ignore the temperature, mean annual temperature, hot in Angola, cold here. They ignore that. However, if you plot these two climatic parameters in one graph, then it gets really interesting. Then you can see that the rainfall, 50, 100, 150, and the temperature, 15 to 25, are forming a line from bottom left to right up. And in the same line, the diameter of fairy circles is increasing from 1 to 2 meters here in the succulent Karoo. These are the colors of the genetic groups, to 50 meters in rare cases, but often 10 to 20 meters in Angola. So there's a hidden relationship between the size. And yeah, so we come to question number 5. to sum up the sand termite hypothesis, do sand termites possess biological abilities that allow to create and maintain fairy circles? Do these fit to the processes of formation, of maintenance, and death of fairy circles? This is an important question because the pure presence is not a proof. One can say there's a correlation, but the causation has not been shown. But the correlation is already good. I'm sure many court cases and crime scenes are happy to have one suspect person in all 1,800 crime cases. Okay, but now we want to look at processes. And I tell you the process. From a fairy circle, a nest, alates, sexual reproductive animals are swarming. They land and couples form a new colony. The new colony is a king and a queen, and they produce workers. In the first year, you have such vague gaps eaten from below. And these first years often are looking like this. They are not circular, they are irregular, and there's no luxury belt at the margin. Most of these are foundations, founder colonies after a very good rain year, and they will disappear within the next 2, 3, 4 years. I could show that in all detail. Okay, so yeah, there are new foundations every now and then, but they can also disappear. And therefore the age discussion is very difficult. I show you a comparison over half a century. The black thing is an aerial photograph from 1956. And the next one is a satellite image from 2006. Doesn't come, okay. Only few red ones died in our picture, and the many stars were added between 1956 and 2006. Meanwhile, they disappeared again because there were quick foundings that died back. So if we calculate on these 1, 2, 3, 4 death cases, then the average age of fairy circles in Marienfluss Valley would be about 1,000 years. If we include these new foundations, several hundred years. So my interpretation is they are very old and they don't move all the time. They are stable in one location, a very important argument. Okay, how can I identify activities of sand termites? By these little soil dumps. They are clean animals. They clean their tunnel every morning and kick out the dirt of the night. And then they leave this, and you can see that on a rainy day. Otherwise, the sun makes the soil dumps fragment. But when you have them, you can count them per square meter, and you see the main activity of the termites is in the center, and then there's nothing at the luxury belt, but outside, where I did not count each square meter, they are again, because there they eat the grasses. Here they killed the grasses, they eat the grasses, but here the water is the important source. So I believe they all the time commute and they go out when they are hungry, and in the dry soil out there after 2 days, they get thirsty and must come back, take up water, and that could be all shown in detail, but then it would be too long. They have many nests. It's not one nest like the Omayova termite. It's a system of nests connected by tunnels that are sometimes empty and sometimes used. And why is this also important? This is a permanent nest where lots of things happen. A black tapetum, Felicitas, the probes you gave around had a black tapetum, which are the northern ones. And you see these sand galleries that are used by the termites to shelter them against the sun and predators when they eat grasses. And they do that in good times. Even they enlarge the circles by killing the inner luxury belt tussocks. It's a slow process, taking years, but during these years, suddenly, after maybe 10 to 20 years, they reach their final size. So there are processes of growing sometimes involved. All these processes are not yet the initial point, but I want to show you that we analyzed in the soil laboratory 235 fairy circle sands inside and outside, and they are all in the sand texture group. There's no loam, there's no clay. The maximum ever found clay was 2%. So it's really pure sand. And in the sand, it's mainly porous sand, porous sand or medium sand. That's what I tried to pitch here. Large soil particles have large intervals, which then allow in these big pores, rapid percolation of water to the depths. It's a three-dimensional system, so you can easily imagine this happens rapidly. And that's what we all observe when we put some water into the sand of the desert. And if the sand is dry, and please later have a look at this fresh dune sand from Duprevier, the water disappears immediately. We all know that. No, you make your hands dirty if you, I don't give it around. Okay, but this is important, the sandy component. I would say 99.9% of all fairy circles are really in deep porous sand. There are few examples where you have dolerite rock, basalt, with a lot of sand between the boulders, where you also have fairy circles. These are Antje Burke and Mary Seeley in Avasip, where in 1991 we saw these strange things that I also find at Geluk, and I find the fairy circle sand termites. So there's enough sand, and there's also the rapid infiltration of a good rain and the storage of water in the depths. If you dig up such a fairy circle, the first 20, 30 centimeters are nasty because they are dry quickly. After a few weeks, evaporation of the water into the air makes that loose sand. So you dig and it falls back and you dig. Only from 20, 30 centimeters onwards, you have wet sand that is stable. And then you are astonished. How is it possible that the sand is wet, even 1 to 2 to 3 years after a rain? And we wanted to make you aware what wet sand means. Can we have light for a short moment? No. Sorry. Here, this is dune sand from Duprevier that has 4 volume% water. And you can see my hand, 4 volume% water is wet sand. And if you like, you can use forms like this as in a children's garden and make forms. This is wet sand that you find even 2 to 3 years after the last rain beneath a fairy circle. And I give it around. You must decide whether you make your hands dirty or not, but you can already see it's dark, it's really wet, and it's 4%. And let me also already now introduce a little experiment that runs since the beginning of our meeting. This is not a cappuccino with chocolate. This is Namib sand from Duprevier, dry sand in the bottom, and 4% moist sand on top. And this, I also want to show you, this sand has been packed here. When did you do that? 5 o'clock this afternoon? We had other glasses like that, where we did it one day earlier. And you see the boundary is still in the same position. And now you can see this glass that has been wetted with 4% exactly measured in the top, and it's 0% down here. And you see the sharp line. Oh, I'm not allowed to go there, sorry. Kannst du das eben einmal bis hinten rum zeigen, dass alle das sehen? And I promise you, the boundary will not move. In spite of this dramatic difference of 4% moist soil and 0%, the water will not move. And this is very, very, very important because that is the basis of the ability of fairy circles to store water for animals for many years. Other people believe that water in the desert rapidly moves. I don't believe that. And this experiment shall show you that it's not happening. It would happen. It would happen if we would have more than 2 or 3% clay or silt. These are smaller particles, and these smaller particles allow capillary water transport between these layers. And then you can have a continuous link of capillary areas from somewhere to somewhere. And then the dry sand in the surrounding will rapidly pull water out of the water storing area, but not sand. sand is an inhibitor if you are below 5% volumetric water content. I will show you a physical formula a bit later. Okay? It's very important. That's also the reason why on clay soils and loam soils you never find fairy circles. If it's okay for you, we go back to the slides. And such trenches, which make you feel that the desert is even hotter than this room right now, when you dig there for 4 or 5 hours, I dug hundreds of these trenches and turned them in simple graphs like that. So if I'm in the trench, I can measure the water content with various devices, and then I can map it. And you can see here on top, that is a fairy circle, the center, half diameter, and here's the luxury belt. So in the middle of the column is the 1 meter depth of soil moisture under the center, half diameter, luxury belt, and matrix. And I used dark blue colors to simulate wet water, moisture containing sand, and yellow to show dry, arid topsoil. And you can see the water is stored really underneath exactly the form of the fairy circle. Because there's rapid infiltration, these coarse interspaces allow that the water, even in a meter, can reach 50, 60, 70 centimeter. And there it is safe and will not disappear. I will show you that in a second. Okay, that I did in, what is it here, 2007, 2008. And then I thought there are equipments that make it easier. These sensors, you can dig into different soil depths, and then they measure in a storage equipment like this over 3 to 4 years. And then after 3 years, you go there again, connect your computer, and load down the data. And I always did this in the same way in the Richtersveld, in many places in Namibia and in Angola, having 4 or 5 depths and measuring, imagine, every 60 minutes. Every 60 minutes at 4 different depths at all these places. And since 2008, and it's still running. And we, meanwhile, for the book, evaluated from 2008 to 2022, too many years, I can't calculate, these ups and downs of water that look like this. So this is, again, Deep Riviere, and there was a rain. Yeah, we were allowed to set up weather stations of the Sascal project. Perhaps some of you know about the Sascal project that I coordinated. If you open this book, it can go through the rows. You know it, you produced it. And these weather stations allow me to tell 46 millimeter here, 27 millimeter there. And then you can see in the depths, the topsoil yellow, 10 centimeters, 30 centimeters, 60, 90. It takes days until the water arrives in the depths. The rain there arrives only here, well, 2 to 3 weeks later, and even 4 or 5 weeks later here. That is the normality, and again here. But here, something strange is happening. There was a rain of 40 millimeter, and that wetted already the soil at 30, 60, 90 centimeter. And the pre-wetted soil, and this is now very important, took the next rain, which is a lot, 89 millimeter, and let it fall through to 90 centimeter in 1 day. That is rapid percolation. So we have these data from 2008 to 2010, published in 2013. I think these are brilliant proofs of what's happening there, especially if we make it a bit more visible. Then here we have Girbisflakte with 5 rain days, total 34 millimeter. They arrive 5 days later at 30, and then 8 days later at 50, and they never arrive at 70. That is a normality. Most rains don't fill up the store. However, strong rains, at average, every second year they do it. And here again, we had the pre-wettening, and then 46 millimeter were good enough to reach 70 centimeter in 1 day. And here are the days, so the data are there. It happens like that. And now comes the other part, the drying. And here we compare the fairy circle, the bare patch that stores water, and that is the matrix. And you can see the bare patch still has 5 volume% at 90 centimeter when the next rain comes, and then it goes up, while the matrix goes down far underneath, beneath 5%, 3% maybe, but that is not good enough for sand termites to survive. Following Sabine Grube, who made experiments with sand termites in the laboratory at Berlin, and she said 5% is okay, but 3 not. So the matrix dries out rapidly. The fairy circle keeps the water and is at almost all times the wettest point in the landscape. Okay, so do fairy circles store water over longer periods of time? Yes, they do. And I showed that already in the science paper in 2013, based on measurements from 2008 to 2012, 5 years of these sophisticated measurements that should please be acknowledged. Yep. Now, yeah, this is just a picture of the ups and downs over almost a decade. No, I don't discuss it. This is interesting. We sometimes had gaps in the data because when I came back after a year and opened the logger, there were termites inside and really wet sand. You can see the tracks of the termites. So they were fascinated to have a compartment where they could bring water in with their bodies. Unfortunately, the data are lost then. The electricity doesn't work with that amount of water, but that gives us an idea how it's possible that queens and kings survive drought periods like the 3 years in Gilbisflakte, or even longer periods in the depths, because the termites with their body can bring water somewhere and deposit it. This was 10 centimeters beneath the soil surface. It's a hot, dry area, and nevertheless, it's filled, but the data are lost. This is perhaps the most important graph I have to show today. It was measured by a soil scientist, Alexander Gröngröf, in a hydrological physics lab. It's soil from Dieprevier, and we brought a big box, and then it can be measured what is the hydraulic conductivity in centimeters per day of this sand when it has 5% humidity, what we gave around 4 or 5%, or 10 or 15, etc. And you can see when it's above 5 or 8%, then there's rapid water transport. That is what I just showed you like this. Then the water moves through these big macro pores between the big sand grains. And then this is now 1 centimeter per day multiplied by the difference in dryness. That is quick water transport. But below 5%, there's nothing. You can see this is 1 billionth of a centimeter per day. Even if the soil outside in the matrix is very dry and very moist inside, this physical curve tells you it's not possible that there is quick water movement. And that's the reason why the water remains there. And that's supported by this experiment. Please have a look whether there's a tiny millimeter moving. Okay, this is physics now, but physical laws are quite hard, as we know from gravitation. Alexander Gröngröf calculated how important is the diameter of a fairy circle. And he found, well, if it's only in the radius of 1.5 meter, it's just good enough to store the water for 1 drought season. So rain in January, still water there in December. But if it goes to 2, 3, 4 meter, more and more water allows years of storage. Okay, that is interesting. I showed you the graph where from Richtersveld, succulent Peru, to Angola, the size of fairy circles got larger and larger. Yeah, the storage may be the important point. So do fairy circles store water over periods of time? Yeah, Alexander Gröngröf, I must highlight. I'm co-author because I collected the data over these decades, but he did the analysis, and this is a very interesting point. And now we come to the end and ask, how do sand termites kill the freshly germinating plants in the bare patch during the annual cleaning process? I think this is very important and should be distinguished carefully. The first creation of a fairy circle is something different from the annual cleaning. Now we look at this, and I again say the reason is subterranean herbivory, And it happens during the weeks after a good rainfall, when the soil is still moist. I can prove that. Starting in the center of the bare patch and then progressing outwards. Yeah, this is just one picture, starting in the center and then dying to the margin. There's still some green plants at the margin. Deep-Riviere, another Deep-Riviere example, still many green plants at the margin and dying here. Yeah, I can really show you pictures over 40 years. I'm not clever. I just had this big opportunity and privilege to work here in this beautiful country for more than 40 years. And that allowed me to experience all these situations. But I also did experiments. This valley we will see on the excursion on the weekend. 3 ferry circles, almost invisible in a dry year, are now combined with a pole with one camera on top and another camera here. And here's the ferry circle in a dry period. And you see a seemingly dead luxury belt. Here are 2 plants, 2 dead tussocks next to each other, and one more is here. That camera looks at this area. And let me run you through the area. At the 2nd of January, the rain did fall. No, as the 3rd. Here we can see the coarseness. There are the 2 plants and the one. No? That's the luxury belt. Here's a bare patch. 3rd of January, 2021. And at the 5th, you see holes and the first germinating grasses. There. I will bring that all on the internet. It's in the book. At the 19th, the plants are almost all out. And at the 30th, they look best. And at the 1st of February, now they start dying in the center. And now all in the center are dead, 7th of February. And then a bit later, at the 22nd of February, all are dead, and the old luxury belt has been reached. You see, they die starting from the center to the outside during the first 4 or 5 weeks after germination, after rainfall. And even at the 26th of March, this area where a ferry circle is still cleaned and the plants are dying, I could measure, on that spot, you see the dark, wet soil, I could measure 13 volume%. So I'm absolutely convinced the grasses die during the wet period short after the rain. They do not dry because of drought stress. There must be another more brutal power killing them. I have an idea. Here we again see the sand termite tunnels, and this is Gilbesflagte. Last year we put, after a rain, day 0, the rain was 12th February, and on day 5, the surviving tussocks in the surrounding matrix get green, and then on day 13, more plants germinate here in the bare patch, but already we see 2 soil dumps. And I imagine there must be a tunnel in that direction. The sand termites woke up and now do their job. And you see more soil dumps also here. Here, a second row. The matrix is very green meanwhile. And I make it short. It can become a movie with 1 picture per day. In the end, these are the soil dumps, and the crosses show the dead grasses. And I would say, yeah, there was 1 tunnel here, 1 here, 1 here. So it's almost a proof like in a soccer game where you can not dig in the soil, but you can see where the termites move and how they kill the plants, starting in the center, going to the outside. Is the damage of the grasses visible? This is the very last point. And here I say, yes, in most cases I can show them, and I want to do that. Not this weekend, because there was no rain this year at Deep-Riviere, but I'm very happy to do other excursions in not too distant future after the next rain. But in most cases, I find the following. Yeah, these grasses have fine roots that keep sand. That is typical. And already Albrecht in 2001 said, if I compare and count many, then only 32 of the roots are covered with sand inside the bare patch, while outside 92%. Okay, it's a vague thing, but he already published that and said there is a difference. While I found something more interesting, I found balls of compacted sand in these young plants at Deep-Riviere. And if you look at them with more magnification, you see it's at the grass seed, exactly at the spot where the plumula is the young shoot, grows out of the seed. And that opens the structure, so it's a point of attack because the grass seed is attackable. And there's the endosperm. The starch is easily found, and therefore we now, if we open that, oops, that was too fast. If we open that and take the sand away, in that spot we see the typical mandible structures of sand termites. You can measure that. It's a mandible size of sand termites, and we know that pattern. So they already start to attack the grasses when they just started. It's quite brutal, but it's helpful because otherwise the fairy circles would not store water because the growing plants would use the water and transpire it with their leaves. Yeah, and later then, that already published 2013, the sand termites create tunnels around the roots, and you see the black tapetum when you open the tunnels, and their sand termite is running away. They live in that, and they kill the roots. There may be two other effects involved. The one is the large number of organic compounds already found by Jankovic, Van Rooyen, and others in the chemical lab in Pretoria. And they exist. They said it comes from deeper earth gas, because the chemical compounds are quite similar. I found them as well at Hamburg University, where I brought my termite nests. And the organic chemist told me, Norbert, you mess around with your diesel in your car. Please bring clean samples. So I went again and packed them carefully, but there was still diesel and other oil and gas compounds. And then we understood they are there, but they don't come from deeper earth. They come from a special stomach the termites have to digest cellulosis. Termites can't do that, but they have a special stomach with bacteria that live without oxygen, and they produce that stuff. And it may be this can help to kill the grasses. I only went so far to measure methane, and the methane production is definitely correlated with living termites in a nest. All the other organic compounds I did not dare, but maybe that is a good research task for the future. And it could also be that one article by microbiologists in this book, it's a Leibniz Institute for Microbiology in Braunschweig, including the director, they published that the blackish tapetum is a reservoir for bacteria and, oh no, sorry, I should have told you earlier. It's a reservoir for bacteria and fungi. In this black stuff, you have thousands of different bacteria. And then, because the black stuff is not only a wall stabilizing tapetum, but it's probably the shit of the termites, then probably also the termites have it on their body. And when they bite into a grass, they may transfer at least 2 plant pathogenic fungi that may also help to kill the grasses. But this we don't know, this may be done. I know this is not perfect, but I think it's quite good. And compared to other approaches to science, my approach is like Max von Frisch, who discovered the language of the bees. If you look at these bees and you try to count, for example, the behavior of 20 of these bees and do that at different beehives, you would probably give up because they all move and you don't see a difference. But if Max von Frisch sits here for days and days and days, then he sees, oops, some do a dance and they have a 8-8 dance, and the 8-8 dance, and now come experiments, tell the other bees how far away is a good fodder tree where they fly to. So I'm very happy to have found very good arguments to say it seems the sand termites are important. And that's my last slide. A short checklist. I think I'm able to say the type locality of fairy circles is inhabited by sand termites. The sand termite fairy circles occur in Angola, Namibia, and South Africa, 1,800. Soil beneath fairy circles, most of the time is moister than the soil beneath matrix vegetation, even during extended periods of drought. extremely slow water movements and sand drier than 5 volume%. They don't move, sorry. Annual dieback starts in the center of the bare patch and then progresses towards the margin. The annual dieback of grass happens in moist soil, and the dieback of grasses is accompanied by expansion of sand termite tunnel systems, as shown in the video, and the damage of the grasses and other plants by sand termites I have shown. You have seen the patterns of the mandibles. And therefore, I now stop and thank you for your interest and long duration of the talk. And another interesting pattern. No, I want to thank you by stopping with the less arid picture, at least some 40,000 of it.
Thank you very much for the energetic and sandy presentation. As usual, Professor Jürgens is very, very energetic when it comes to plants. I had the chance of being with him on an excursion, and the most fun thing for me was to see him jump out of a car, lie on the floor with his camera, and taking hundreds of pictures of something. And now I still don't like termites. Now that you've got even more, I like them even less. Before I hand over the microphone to the floor for questions, I would like to give the microphone over to Klaus Hess from the Klaus Hess Verlag. Please be so kind to introduce yourself, the Verlag, as well as why this book.
Yeah, thank you very much, Ruth, for the introduction. Ladies and gentlemen, good evening. I'm quite happy to be here today with you. Quite a number of you, I'm sure, know me since decades because I'm involved in the Namibian-German relations as president of the German Namibia Society since now more than 40 years. And during this time, you know, we as a German Namibian Society are active to bring a lot of informations on Namibia into Germany. And so it happened 2 or 3 occasions that I could listen to Norbert Jürgens when he made presentations on his findings on regional meetings we had organized, for instance, in Frankfurt, in Palmengarten, I do remember, and another time when we had a weekend seminar, you joined in, and it was always fascinating to listen to him and to explain quite complicated scientific matters in a way that even laymen like myself with, I should say, standard intellectual properties are able to understand it, or at least to have the impression I have understood it. So, and so in 1995, I started my own publishing house, and I think quite a number of you are familiar with a lot of books. You know, I think about 50 up to now I've published on Namibian topics of various kinds. And so I felt very much honored when Norbert approached me a couple of 3 or 4 years ago, asking whether I would like to publish all his findings in this book. And should take about 6 to 8 months, you know, that we could finalize it. That was 3 years ago. And so I said, well, quite an honor, because I felt quite convinced about all his findings. And so I said, okay, I do it. And so we made up a time plan, you know, and well, we moved it a little bit, we moved it, and there was some review and another review and a third and a fourth and a review, because there are 2 editors I would like to mention. That is Ute Schmiedel and Manfred Fink. They are responsible for all this editing and reviews and all this. And so it took some time, and then we had Corona problems, of course, as well. And I sat there during Corona, what should I do? I waited for the book and the text to make the layout and so. But now, finally, last year we succeeded. And so from, I think, April onwards, I got all the texts and the pictures, and I was overwhelmed by the number of pictures, you know, that were presented to me and sent to me. And then I started doing all the layout by myself. And so I got into the matter as far as I was able to understand it. And I must say, I was absolutely delighted, especially about the number of documentary pictures there are, yeah, and not only words describing something, but really explaining, you know, that you could really see and follow what is the facts and the matters, you know, described in all the findings and explanations. So that's it, and then we succeeded at the end of the day just to finalize and to print the book, that it reached roughly to lay under the Christmas tree on 22nd of December last year. And then we moved quite a number of these books here to Namibia, because of course I'm present as a big publisher in Germany as well as Namibia. And so I'm cooperating here with Angela Hofmeier from Namibia Book Market. She is present here. She is my agent, and she is active, you know, to bring this book into the market. And well, it is, I think the facts on the book are mentioned already: 376 pages, 780 pictures, and 15 tables, and so. And we can offer this book tonight for a special price of $780 NAM. And as an addition, an extra for all of you who are here, Norbert Jürgens is prepared, if you want, to sign the book, you know, sagt man signieren in German, yeah, autograph, so that you've always got a very special, personal, individual copy for yourself, you know, which there is no other, because even the signature differs a little bit, yeah. So every book is a very single copy. Yeah, that's it. And please, as they have been mentioned, these living stones, just a small ad block from my side. 3 years or 4 years ago, I have published a book on wild lithops from Harald Jainta and his wife, who have been for years underway here in Namibia and in South Africa to find out all places where there are these lithops, these living stones, and there are even 2,000 pictures included, 2,000, yeah. And so it's for everybody who is interested in this matter, I could really say that it's a most excellent publication on this matter, these living stones and lithops in the wild. Thanks. So far from my side. Thank you very much that you have attended here. And so I think now we come to questions and answers. Thank you.
Okay, considering that we've got 8:30, few questions. Have we got anything on the Zooming side? No. I'm now.
Thanks for the talk. It was quite interesting. My name is Stefan Getzin, University of Göttingen, and we had already some disputes in the past, and it's still going on, but it's also fun. We published in October 2022 an article where we clearly show that the grasses die without any root herbivory, without any termite presence. The root length of the grasses was even significantly longer inside the circles than outside, which by definition excludes herbivory by termites, because the consumption of biomass leads always to shorter roots, to reduced root biomass. And this did not happen. And we excavated a large databases, 500 grasses in the southern Namib, central Namib, northern Namib. And we clearly showed that the grasses die of plant water stress because the upper 10 centimeters where the grasses get going, try to germinate, is drier than in the matrix. Even your own data show it in the book. I can show it to the audience. We can open the book. And the grasses invested into these longer roots because they search for water, and termites were not present. And then the New York Times asked several fairy circle researchers, completely different fairy circle researchers, and they all agreed that our data conclusively show that sand termites are not causing the fairy circles. Now, the difference between our data set and your book is that you present at no position in the book real data in support of the hypothesis that the grasses would die in a green stage. The core of your hypothesis is that the green grasses die due to root herbivory. And this can be shown by replicates, by measurements, and by statistical significance test, which is the cornerstone of scientific work. But in your entire book, you dedicate half a page of text to the claim that the green grasses would die due to root herbivory, not more. The other 375 pages deal with something else. And I want to highlight that in science, you have to work with replications. So you would have to show, based on hundreds of green grasses, that the grasses die due to root herbivory in a green stage, not in a dry stage. You would have to show measurements. A scientist has to show measurements. The root lengths would be shorter. The biomass would be shorter. You have not done this in the past 10 years. And you would have to show significance tests. And also this does not exist to actually show that there is a significant effect of root herbivory.
But with this or that? Okay. No, thank you for the advice how to work scientifically. With my, this year, 70 years in science, I appreciate it. Regarding the data shown in the book, I propose, try again. Please have a second read and you will find the data. Okay, then we, after a while, can ask other people who can also read. Be happy that I only wrote a certain length of a chapter on this one aspect, and be happy that so many other aspects are also covered that one could also discuss in length as proofs. And perhaps this is necessary, depending on the selling success of the book. I'm sorry to say, I already prepared a second edition with many other additional data, but some other data we will also place on a web page, especially those videos and movies that can enable everybody on this planet to see what's happening there. Regarding the death of grasses, what I showed last, the annual cleaning process, I disagree with you. I showed my data here. I showed them in the book. I can show them again once we have another good rain. I think the problem with your article, against which Alexander Gröngrove, the soil scientist, and I wrote a response letter addressing many of these points and submitted that to the same journal. And I understand it's still in review, so we will earlier or later know what reviewers will tell about it. We asked the editor specifically to involve hydrologists, soil scientists, maybe people from physics, to really look at the natural laws involved and what may be possible. We can happily have more discussions also in the public on this topic. I'm extremely relaxed because, I have seen so many different aspects of the vericircles and the sand termites that I can happily wait until everybody else has seen the same.
Any more questions from the floor?
This is probably a stupid question, but if the ants are making new circles by flying to new places, why isn't, after hundreds of years, the entire country covered, the entire area covered closely with fairy circles? Why don't they become incredibly dense?
Yeah, sorry, I must stand there. Well, that opens a very complicated discussion. I tried to find older documents, also including ethnological documents, but I was successful too late. And only in November, when the book was already in print, I got knowledge from archaeologist who also for Namibia found proofs or mythological ideas, for example, from Damara region, explaining other explanations of fairy circles. This was new, I never heard it before, and therefore I only followed the modern path of modern publications, which started, as I showed you, with 1971. It may be that in a second edition, sorry. Okay, thank you. We should include some archaeologists and historians. And meanwhile, there is a good discussion. And interestingly, that discussion now widens by including the colleagues from Australia, who also have a similar discussion whether fairy circles there are somehow related to termites or not. And yeah, already for a number of months, there's a preprint in the internet, obviously submitted to one of the nature journals, telling that they dug up 100% of all the fairy circles interpreted by Stefan Getzin, and they found termites in all of them. So even there, the same debate is in the air, and we will see with new publications and new evidence and maybe debates, and also there, yeah, every debate is welcome, whether there we have the same pattern. So it's a very lively research topic, that's for sure. And also the field hall here shows that there's a lot of interest in Namibia. I'm sure the discussion will go on, and I will happily be available if field excursions should be done, perhaps organized by you. I would definitely recommend to include Angola and South Africa, especially the Richtersveld and the Spurgebiet, now Tsaukaip National Park. It's really, really interesting what diversity of forms you find there. Yeah, and the next publications will come.
One more question.
The Richtersveld circles you showed were not associated with grasses, but with succulents. So, but you didn't show any termites involved there. What did you find any there? Were they eating the succulents or?
Sorry, I didn't get.
Yeah, one. Okay, so better, yeah. The fairy circles in South Africa and the Richtersveld you showed were not associated with grasses, but with mesons or succulent plants. You didn't show if there were any termites associated with that. Did you find anything? And if they did, they feed on the succulents?
Yes, maybe I misunderstand you now, but what Felicitas has shown, the most ancient evolutionary group at the very basis, the first ones producing fairy circles, they are already a psammotermous group that now will become a species. And that is the species that will retain the published name Allocerus. Allocerus means different teeth, asymmetric teeth, because the type specimen was collected at Lüderitz. And at Lüderitz, you have that type of succulent Karoo fairy circle that you find throughout the western and southwestern part of the Spurgebiet. And in the Richtersveld, from Alexander Bay, starting 5 kilometers from Alexander Bay, going through the Hulsandveld, to almost Kubus, but not reaching Numis. In Numis, you already have the inland species that also inhabit the whole Garib Valley towards Uppington, Bushmanland. So there's very clear genetically from the behavior, they are plant eating, and there they eat the roots of Otana, of Pronanthus, so not grasses, but all these mesums and other woody plants. And we can show that in all detail. I wonder whether I understood your question correctly. And the termites are there. Okay, thank you.
Okay, with
Everybody?
this, I would like to close the evening. Invite you for a glass of wine, to purchase a book, to have a signature, look at some sand, look at some nests. Thank you very much for the wonderful presentation. Thank you very much for the, and with that, I wish you a lovely evening.